Frequency is the number of complete wavelengths that pass a point in a given time. Pitch is a tone's experienced highness or lowness. It depends on frequency. The amplitude is the height of each sound wave. The higher the amplitude, the louder the sound.
Sounds of a lower pitch, or frequency, produce a slower rate of vibration. And sounds of lower volume, or amplitude, produce a less dramatic vibration. Higher frequency sounds produce faster vibrations.
Decibel is a measure of sound intensity.
You know that distance is measured in miles and that weight is measured in pounds. But did you know that sound is measured in decibels? Decibel levels begin at 0, which is almost total silence. As sound gets louder, the decibels increase. Decibel levels under 85 are considered safe for your hearing for an unlimited amount of time. The louder the sound, the less time you can listen safely. A normal conversation is at 60 decibels. Heavy city traffic or a school cafeteria is at that 85 decibel threshold. A symphony orchestra can top out at 110 decibels. For hearing health, we should be aware of the loudness of the sounds that surround us and protect our ears.
Pinna is the outer ear that funnels sound waves.
The pinna, also known as the auricle, is the visible portion of the ear that is extremely seen. This helps in locating sound sources and directs the sound into the ear. This does not play any role in maintaining the balance of sound.
The tympanic membrane is a thin membrane that separates your eardrum from the outer and middle ear.
As sound enters the ear, it passes through the external auditory canal, where it meets the tympanic membrane. The tympanic membrane then vibrates in response to the sound. The tympanic membrane is cone-shaped and articulates with a chain of 3 bones called the auditory ossicles.
The ossicles have 3 small bones, the malleus, which is the hammer, the incus, which is the anvil, the stapes, which is the stirrups. They conduct the sound waves through the fluid of the cochlea.
The hammer, on receiving the vibrations from the eardrum, sends them to the anvil. That in turn passes them to the stirrup, and these are then passed to the inner ear.
The cochlea is a small fluid-filled tube in the inner ear where sound waves trigger nerve impulses.
The cochlea, which is a fluid-filled snail-like structure that contains the receptor organ for hearing. Let's unwind the cochlea to get a closer look. In this enlarged cut view, you can see the spiral organ of Corti, which is the receptor organ for hearing. It consists of tiny hair cells that translate the fluid vibrations of sounds from its surrounding ducts into electrical impulses that are carried to the brain by sensory nerves. Let's take a look at this process in action. As the stapes rocks back and forth against the oval window, it transmits pressure waves of sound through the fluid of the cochlea, sending the organ of Corti in the cochlear duct into motion. The fibers near the cochlear apex resonate to lower frequency sound, while fibers near the oval window respond to higher frequency sound.
The middle ear is the space between the eardrum and the inner ear that concentrates the vibrations of the eardrum on the cochlea's oval window. The inner ear is the innermost part of the ear that contains the cochlea, semicircular canals, and vestibular sacs.